Hello, everyone. Thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Roger Berlin. Today, we're going to talk mainly about HashiCorp Nomad. So HashiCorp Nomad is a simple and flexible workload orchestrator to deploy and manage containers and non-containerized applications across on-prem and clouds at scale. Nomad's enterprise governance and policy module includes namespaces, resource quotas, Sentinel policies, and preemption for service and batch jobs. These features allow multiple teams to share a Nomad cluster while ensuring that no team hogs the cluster's resources and that mission-critical production jobs will be allowed to run even if non-production teams schedule more jobs than expected. So during this SE Hangout, Roger will demonstrate how to apply governance and policy for multiple teams sharing a Nomad cluster with a hands-on instruct track. So I also want to note that the Hangout is being recorded and it will be made available after post-processing, usually within a day or two, and I will email it out to all of you. So the demo will be about, and presentation will be about 25 to 30 minutes, and then we'll allow the rest of the time for questions. So please submit any questions you have through our Q&A portal, and we will answer those during the Q&A section. So with that, let's go ahead and get started. Take it away, Roger.
Okay, thank you so much, Brianna. Thank you, everybody, for participating. So again, Roger Berlin, I'm a technology specialist with HashiCorp. I've been here about over 2.5 years, and I specialize in both Nomad and in Sentinel, which is our governance as code, policy as code solution that's used across our enterprise products, including Nomad. So this is the agenda for what I want to cover in the next half hour or 35 minutes. I want to give you a brief overview of Nomad, and then I would like to talk about some key Nomad features that enable teams to share clusters together in a multi-tenant situation. I also want to give you the demo that Brianna already mentioned, which is a hands-on instruct track. Instruct is a learning platform that we've standardized on here at HashiCorp for, at least within the solutions engineering or SE pre-sales organization, we're using for demos and for workshops. And then I'm going to give you some information about a hands-on Introduction to Nomad workshop that we're going to be delivering next Wednesday from 10:30 a.m. to 3:30 p.m. Eastern time. I'll have some more information about that at the end, and we'll do some Q&A. So with that, let me go in and give you a brief overview of Nomad. Nomad is an easy-to-use and flexible workload orchestrator that enables organizations to automate the deployment of both containerized and non-containerized applications in private and in public clouds. So that's an important point, by the way, that you don't have to necessarily take your applications and Dockerize them or put them in containers in order to run them in Nomad. And we do support both Windows and Linux. So there's some extra flexibility with Nomad that you don't necessarily have with some other orchestration solutions that are out there. So we do provide a single workflow that will work across multiple clouds. Obviously, the big public clouds like AWS and Azure and Google and other clouds, as well as your own private clouds within your data centers. And the green bar there is representing Nomad as this kind of interface between, basically Nomad is allowing multiple resource pools, VMs, with compute and memory resources, networking resources to be shared by these applications. One of the advantages of Nomad is that it has a single binary that is used both for the Nomad servers that manage a cluster and for by the Nomad clients, which are where the applications actually run. So Nomad has a very simple architecture, very simple design. You don't have a lot of different pieces to deal with and configure and worry about. It's very simple to download the small binary and start running Nomad servers and clients. And Nomad increases density and reduces costs through something called bin packing, which we see in the bottom row over here. If you don't have bin packing, you might have a number of different applications of different sizes, and they may end up being distributed, in this case, across 3 VMs, or 3 servers. But with bin packing, we get higher efficiency. And now Nomad was able to put the same applications onto 2 servers, leaving the 3rd server free for additional applications that might otherwise not have fit into the 3 servers. And sorry, I'm just going to move the video out of the way. Why do companies use Nomad? The main reasons are ease of use. It's easy for developers to run their applications, and it's easy for operators to manage the clusters. Workload flexibility. As I mentioned earlier, we support Docker and also non-containerized or legacy applications on both Linux and Windows. Scalability is another important factor. You can create very large federations. You could federate multiple clusters across multiple regions and even multiple clouds. So you're not limited to running a cluster within a single cloud. And also, Nomad has excellent synergy with other HashiCorp solutions. And that includes integration with Vault for secrets so that your applications can retrieve secrets from Vault. And Nomad takes care of handling the Vault tokens and renewing those tokens and making the leases on the secrets and all that, if you're familiar with Vault. And then also integration with Console in two different ways, actually. One is using Console for service discovery so that your applications running can, anytime you run a Nomad job with these applications, they will be registered as Console services, or at least that's an option to you within your Nomad job specification. And so those applications will be able to find each other, even if Nomad ends up moving them around between the different Nomad clients. And then also configuration. And then also there's integration with something called Console Connect, which is an extension of Console that provides security between applications that are talking to each other through Console. Console Connect fundamentally is restricting which applications can talk to other applications. And it also, by the way, uses mutual TLS between those apps. So I did want to briefly mention one case study, one example of a customer who's using Nomad, at large scale is Roblox, online gaming company. They have over 11,000 nodes across 20 nodes, meaning their applications across 20 Nomad clusters. So actually, no, sorry, that's 11,000 Nomad client nodes across 20 different Nomad clusters on both bare metal and in AWS. And they manage all this with just 4 site reliability engineers. So 4 SREs are managing this because Nomad is so easy to manage. And they have 400 developers who are deploying different applications, different games to Nomad. Typically, their time to deploy an application globally is less than 8 minutes. And they've doubled the number of game servers that they're able to run on the same hardware. So it's a pretty good success story. And this is a success story actually that will be covered next Wednesday during the workshop that we'll be doing. Our product marketing manager, Chung Lee, will be talking for 30 minutes about this case study in more detail. So if you would like to learn about that, that's another reason to join the workshop at the beginning. Okay, so I mentioned earlier, I want to talk about some key Nomad features. These are features that allow multiple teams to coexist within a single Nomad cluster. Now, the first thing is the Nomad Access Control List System, or ACL system, which combines ACL policies and ACL tokens. You define policies that have different capabilities to do different things within the Nomad system. And then ACL tokens are assigned policies. So different people can be assigned different tokens, and we'll see that in the demo. And so those tokens, because of the policies they have, affect what the users can do. We also then have Nomad Namespaces. Nomad Namespaces allow a single multi-region Nomad deployment to be shared by many teams without conflict. Jobs in different namespaces can actually have the same name. So if you want to have a dev namespace, a QA namespace, and a production namespace, you can have a job called website, and it can be use the same job name in all 3 namespaces without conflicting with each other. Of course, you would probably configure those 3 job specifications a little bit differently in terms of the resources that might be needed and things like that. But they're allowed; they're not going to conflict with each other. So that's good from the point of view of lifecycle management of applications. Also, ACL policies are used to restrict which users can run jobs in different namespaces, and the namespaces are automatically replicated across federated clusters. So you create a namespace in one cluster, it will be available in other clusters that are connected to it. Same thing with resource quotas. Resource quotas restrict the aggregate resources that each namespace can use. Primarily, we're talking about CPU and memory resources, but also networking resources. And these prevent any one team or user from adversely impacting the other teams, right? If each team is limited to a certain amount of resources within the Nomad cluster, they can't schedule a whole bunch of jobs that suddenly consume all the resources of the cluster, and that would thereby stop the other teams from doing the work they need to do or from running their applications. So again, ACL policies are used to restrict who can change resource quotas, and resource quotas can be defined for each region or they can be applied globally. And then the last of the four concepts, Nomad concepts I wanted to talk about is our Sentinel policies. Sentinel expresses policy as code. This is something that HashiCorp created about 3 years ago. Sentinel has its own language, which is a very simple, easy to learn language for defining policy as code. Just in the way that Terraform, does infrastructure as code, Sentinel defines policy as code to make sure that policies are really being applied. Now, Nomad, Sentinel can restrict jobs and the drivers that they use, and Sentinel policies are applied when you submit a job, either to run a brand new job or to update an existing job. Now, the Sentinel policies are only run, we can see this on the bottom, they're only run if the ACL policies indicate that the person, or really the token, who's trying to submit a job is actually allowed to do it. So, the process is first, the ACL token is checked, and then Nomad checks the ACL policy associated with that token to see, hey, is this person allowed to do what they're trying to do? And then Sentinel imposes additional restrictions, so restrictions like, whether the Docker image is allowed, whether there are other properties of, the job specification that are allowed or not allowed, et cetera. And if all the Sentinel policies pass, then the job can be deployed. And when I say a job, that's basically the nomenclature in Nomad for deploying one or more applications. Okay, there is, by the way, one thing with Sentinel, or two things worth pointing out, is that there is a possibility of Sentinel jobs being overridden. We're going to see this a little bit later, but Sentinel policies actually can have 3 different enforcement levels. They can be advisory, soft mandatory, or hard mandatory. Advisory just is kind of for logging purposes. It doesn't stop anything from happening. A soft mandatory policy that can be overridden by people with the Sentinel override, ACL policy, but they can do that. Those people, but not obviously other people would not be able to override it and go ahead. Whereas a hard mandatory policy can never be overridden by anybody. Okay, so with that, I'm ready to go ahead and do the demo. I'm going to switch over to the instruct environment. I'm sorry, I want to first set up the demo environment a little bit. Let me explain what I'm going to be doing. So in this demo environment, which is running inside an instruct track that I've already started, I have one Nomad server with 3 Nomad clients in Google's Compute Cloud, or Google Compute Platform, sorry. And we have 2 different teams for which we are creating namespaces. We have the dev team and the QA team. Each team has its own namespace with an associated resource quota that's been applied to the namespace. Alice is a developer on the dev team, and she has an ACL token. Bob's an engineer on the QA team, and he has an ACL token. And then Charlie is an infrastructure manager allowed to override violations of the soft mandatory Sentinel policies that I just talked about. And you can do that in all namespaces. So we have 3 different users. And as I go through the demo, I'll be exporting their token. Effectively, I'll be putting on different hats, right? I'll pretend to be Alice, I'll pretend to be Bob, I'll pretend to be Charlie, and we'll see what happens when I run different jobs. We also have 3 Sentinel policies that are going to restrict jobs. I'll show those to you during the demo, and we'll see what happens when the 3 users try to run these different jobs in different namespaces. The demo implementation is actually available for you. This is a public instruct track that anybody can run at the URL given there. It's a little bit of a funny URL because while it's a public track, we want to be able to track people who might run that. So you do have to register or sign up, which is very easy with instruct. And then if you use this URL to run the track, we will be able to see that you ran it and capture your email. But that's it. There's no other information that you have to share with us, at least. And so we encourage people to run this track so that you can see for yourself what it's like to run a Nomad Enterprise cluster and to use the Nomad Enterprise governance features. The full demo flow, if I were doing this from scratch, would be to verify the health of the cluster, configure Nomad namespaces and resource quotas, create the Nomad ACL policies and tokens, then create the the Sentinel policies, and then run the Nomad jobs. First run some jobs that are restricted by ACL and Sentinel policies, and then run Nomad jobs that are restricted by resource quotas. Now I'm going to basically start at step 5, but I am going to show you what I created in steps 2 through 4. So with that, let's go over to instruct. We can see I've completed 67% of the track. I have green check marks indicated that I already verified the health of the cluster and that I created all the things that I just mentioned. But let's actually go in and take a look at some of these. So I can go back, even though, I've already completed those challenges. I can go in, the way Instruct is set up is that you have an assignment on the right that you're supposed to follow. There's also these note screens where you can look at the notes that show up at the beginning of each challenge, but you can also hide the assignment if you want to get more real estate available to you. I have my whole screen, so I have plenty of room here. These are the commands that I ran to apply or to create the resource quotas. I did this for the default resource quota, the dev, and the QA. We can take a look at these quotas. And over here, we see what they look like. The default resource quota, which ultimately gets applied to the default namespace, it's global in scope, and it's allowed to use 2300 megahertz of CPU and 3100 megabytes of memory. The other two namespaces are very similar. They have the same CPU limit, but a little higher memory. You can see that the QA and the dev quotas are exactly the same. Now, by the way, what I can also show you is I can show you the ACLs get created a little bit later, but while I'm thinking of it, this is the boot. I saved all the, you wouldn't normally do this in production, but I saved the various tokens that were created into files so that I could use them. And this is the bootstrap, or the management token that is created at the very beginning when I enabled the ACL system for Nomad. What I'm going to do, just so I don't forget later, is I am pasting this into the UI so that later on I will then have the ability to see everything in the UI, because I'm now logged in. Think of it as being logged in with the management token, the bootstrap token. We can see I have 3 Nomad clients, as I mentioned in my slide, and I have 1 Nomad server. And currently we don't have any jobs running. Okay, so with that, we looked at we see the ACLs and the quotas. Let's go back to the list of the commands. The commands that you need to do are always highlighted in black, and you actually, for most of these, can just click and then copy and paste. Here we can see the commands that I use to create the namespaces and apply the resource quotas to them. That's done in a single operation. So I created the default namespace, the dev namespace, and the QA namespace. And then down here, if we want, we can actually run a few commands to show us some of these. We see the Nomad namespace list. We see, the 3 namespaces I mentioned up here. We also namespace status of dev. We can see, what's going, the dev namespace, what resource quotas applied to it, what the quota limits are. So we see, the limits that I already showed you. And then we can see a list of the resource quotas, which are the 3 that I'd already mentioned. So I don't particularly care about this last command. I won't run that. But we can see where, that's pretty much what was done in this particular challenge. But now let me move on and show you the ACL policies and tokens. I already showed you the Bootstrap ACL, but the ACL system in Nomad is enabled by adding a stanza to the Nomad server configuration file, and then also for the client configuration file. So we have the exact same stanza for all of them. So what happens in this challenge, if I'd been running through this, I would have actually added, well, that's added for you, but we would navigate to a particular directory, restart Nomad, then generate the Bootstrap token, which I already showed you. And then we can export that and then restart the Nomad clients. So that's what went on there. And then what I did, or what I did earlier before you guys joined, is I created the policies. I created the anonymous policy so that a user who's logged in to the UI, who's using the UI without having logged in, that there's still certain things that they can do anonymously. I created the dev policy, the QA policy, and the override policy. And we can see what those policies look like, over here. These are the, yeah, that should be right. Yeah, ACL dev, this is the ACL dev policy, right? So this is saying that for the dev namespace, they can write policies, and then they have certain permissions, read permissions on agent and nodes, and they can list jobs in the default namespace. So the developers can effectively look at jobs in the default namespace, they can list them, and they can run jobs in the dev namespace. We have something similar for QA. They can list jobs in the default namespace, and they can create jobs, or the right permission lets them run jobs in the QA namespace. So this means Alice will be able to run jobs in the dev namespace, and Bob will be able to run jobs in the QA namespace. And then there were commands that I ran to create the tokens. We see the Alice token, the Bob token, right? Here's the Bob token. All right, and we have Charlie's token. So these are the 3 tokens I generated in addition to the Bootstrap token. So that's all there. And again, we have commands that we can run if we wanted to. to see, verify that we have the 4 ACL policies, and we can look at one of them, and then we can list our tokens, and we have the 4 tokens that I mentioned and showed you already. Okay, so with that, I'm actually now that sorry, one more thing is the policies. Let me show you the Sentinel policies that we have. We actually have 3 of them. The first one is a policy that only allows this cluster, within this cluster, people who are running jobs can only use jobs that use the Docker or the Java or the Java driver. Nomad has multiple drivers for doing different things. There's, for instance, there's also an exec driver that can let you run an arbitrary binary. You can actually take a quick look at that here. It's called task drivers. So these are the official, drivers managed and supported by HashiCorp, Docker, isolated fork exec, Java, Camu, raw fork exec. And then there are also some community supported drivers for a number of things. So we support a lot of different things in terms of what you might want to do with Nomad. But in any case, in this particular cluster, this Sentinel policy is saying we can only use the Docker and the Java drivers. Then we also have a second policy that says we're only allowed to run certain Docker images. We can run Nginx and Mongo. But in addition to that, we have another rule here saying that the Docker image has to match something in the allowed list, which was up here. Well, this is a little confusing. We're iterating over the allowed images list, and then for each one of them, we're saying, basically we're requiring that one of these has to be true. For one of these guys in the list, we need the image name to match whatever the item in the list is, plus a colon, plus some kind of number, something starting with numbers. The reason we're doing that is we don't want to allow the latest tag. For those who know Docker, you can run a Docker, you can specify a Docker image with a tag that's equal to latest, in which case you get the latest version of that image. That's not really a good idea in production because somebody could change, do an update to that, and that could break your application. So those are the 3 rules that we have. Oh, sorry, one more. We have this third policy is saying that this is for Docker specifically. We're saying that the network mode of a task should not be host. The Docker driver allows you to use the host network, bridge network, and some custom networks. We're saying you cannot use the host network because that gives the Docker container access to things on the host network itself. So those are our policies, and we can see here that those were created with Nomad CLI commands to create all 3 of those policies. And just to verify that they're all there, we can actually list them, and we can read one of these policies as well and see what's in there. And we can see, for instance, the enforcement level on that one is soft mandatory. Okay, so that means that Charlie, for instance, could override this policy if somebody wanted to deploy a job that it does not use one of the allowed images. So with that, let me go ahead and actually now let's start to run some jobs. So we're going to run Nomad jobs and learn how this all works. And in this case, we're going to be focusing on jobs that that won't be allowed to run in some cases because of the ACL policies or the Sentinel policies. So I'll start this challenge. I'm going to navigate to the directory with the policies, or with the jobs, sorry. And the first thing I'm going to do is take a look at the Nomad, the sleep job. The sleep job, notice this is scheduled to, or this is designating that it wants to run in the default namespace. And but it's using a driver called the exec driver. This is the driver that can run any arbitrary binary, in this case, the sleep command. And it's basically just saying, it's rather trivial, we're going to sleep for 60 seconds. But that's not allowed by the policy that restricts which drivers can be used. But let's try to run it anyways. When we do that, sure enough, we see a message saying that allow Docker and Java drivers policy, that policy has been violated. Okay, so that's what happened there. So we're not going to run that one. And of course, if we look at the Nomad UI, it's not running because it was blocked. Now what we can do is we can look at another job. We have a job called Catalog Nomad. This job has a few different problems, but in particular, notice that the image is not one of the allowed images. It's from my own personal Docker Hub account, rberlin catalog latest. It's also using latest, which is not allowed. And it has network mode host, which is not allowed. But let's try to run it anyways and see what happens. Again, we get a warning about the host network being violated. Now, you might wonder why we're not seeing violations of both policies. That's because the way Sentinel works is as soon as one policy is violated, it stops evaluating the other ones because it knows the job cannot be run. So it just immediately, tells you, hey, you can't run this. So we'll see in a second though what happens. So what I'm going to do is we can make some changes here. We can try to fix up this job so that we can run it. I could edit the file manually. I could go, for instance, change host network to bridge network and stuff like that. But I'll just use the sed command to do it. A little easier for me. And if we come back to the file, now we see that it says bridge. So that's good. We could try to now run the job again. And of course, at this point, we're still going to have a problem because now we see we fixed the problem with the one policy, but now we have restrict Docker images as being violated. But what we can do is we could just override the job, because I should have mentioned, by the way, if up top here, if I echo my Nomad token, I'm actually using the bootstrap token. If I echo that Nomad token that's currently set, it starts with A4739. And if we look here, remember at the bootstrap token, that starts with A4739 as well. So I'm using the bootstrap token. And that means the bootstrap token is not, has all permissions. So that means including the override permission, the Sentinel override permission. So if we come down here, I can now run this command with the policy override. So I'm going to run the job again, but with the policy override flag. And at this point, I get a yellow warning message about the policy being violated, but Nomad does continue and it does deploy the job. And we can see in the Nomad UI now that the catalog job is running, or at least it's being started. The deployment is running. We see there's one allocation that's been placed, and we're waiting for that to be healthy. So, I don't particularly, that'll eventually become healthy, but what we do is move on to the next job that we want to look at. So that just actually did become healthy. If we look at the web server test Nomad job, this is a job that wants to be run in the QA namespace, which means only somebody with permission to run it in the QA namespace can do it. We have a count of 2 web servers, but then we have some other issues with this job. It's trying to run the Apache HTTPD image, which is not allowed. Right, so we'll have to fix those things eventually, but let's first try to run this with Alice's token. So what I'm doing is I'm exporting Alice's token, and then I'm going to have Alice try to run this job. And when she does that, she gets a 403 error. So in this case, it's the ACL policy, that said, hey, no, Alice, you don't have permission to run this job. It's in the QA namespace. You only have permission to run jobs in the dev namespace. So Alice can't run that job. So that again shows, this is all important, right? Because Nomad not letting people do things they're not supposed to do is that's what governance fundamentally is about. It's annoying to the people who maybe aren't allowed to do what they want to do, but this is because the security team or other teams are trying to enforce certain policies. So now what we can do is now let's export Bob's token. I'll put on Bob's hat, and now let's try to run this job. And what we see is we get a warning about the Docker images not being allowed, because it's HTTPD instead of Nginx. Now he might be tempted to use the override command, but he doesn't have that permission. But let's go ahead and have him try that anyways. Maybe he thinks, hey, I'll just override that. I don't care about company policy. Well, he gets a 403 error because he's not allowed. He's allowed to run jobs in the namespace, but he's not allowed to override soft mandatory policies. So he's going to actually have to fix the application. What we can do, I could do this with this command, or I can do it manually if we want. I could come in here and I could change this to, Nginx, let's say, which is what Nginx, sorry, there we go, Nginx, and I can save that. And I think there's only one occurrence of that. So if I run this again, oops, sorry, let's run the previous job, this one. So this is still complaining about the Docker image. Why is it still complaining? Well, remember, I didn't fix the tag. I also have to fix this tag. I have to have a valid tag. So let's go ahead and fix that. I'll do it with sed this time. We can come over here and now see that now we see the correct tag that's been added there. And now finally, we can try to run the job once more. And this time it is run. And if we come over here to the Nomad UI, now we're not going to see anything in the default namespace, right? This job's running in the QA namespace, so we have to switch over there. And we can see that this job is, currently in the process of being deployed. 2 allocations have been placed, and they just became healthy. So that is that, except one more thing on this challenge is we want to show how, the idea here is we want to show how Charlie can override policies because he does have permission. So what we're saying here is that, hey, Bob's running his website for a few days on Nginx, and then he realizes that some pages are not loading. And so he decides he wants to switch back, or he asks Charlie for permission to switch back to Apache so he can get things running the way they were before while he fixes up Nginx. So let's go back to the server. Let's actually do that replacement. So we'll switch back to HTTPD, but we'll also give it a valid tag. Let's just see. This should be over. Then now we see that's updated. HTTPD:2.4. And now let's also export Charlie's token. So we'll pretend to be Charlie. And now Charlie's going to run that job with the policy override. So he does that. He gets a warning, but that's okay. And if we come here, we can see that this job is currently being redeployed. There's one new one starting and one running, one complete. So we see that Charlie was able to basically run this job with the Apache web server instead of Nginx. And I do have to wait for all of those to be healthy. Once they're all healthy, I can click the check button and move on to the next and final challenge, which is to show how resource quotas can also limit what people can do. So just bear with me for 10 seconds here, maybe still 15 seconds, hopefully. We'll just wait for that to be healthy. You can also check the status. There we go. So it's healthy now. There's also a CLI command that we could check the health with as well. So I click the check button, and that says correct, and it's going to now let me move on to the next challenge. And then I can wait for the start button, click the start button, and I have to navigate back to the jobs directory. And having done that, what I'm going to do is export Alice's token again. And what we want to do is we're going to, first of all, take a look at the resource quota for the dev namespace. I run that command. Remember, there are no jobs running there yet, so it's all 0. So we're good, which means she should be able to run a job. Now, it's the instructions. They suggest that we should look at the website dev nomad job. So let's take a look at that. We see here a number of things. We see here that it's running Nginx, which is good. Well, more importantly here in the driver, in the image, Nginx with a valid tag. It's going to run 2 of those. And then each one of those is going to want 250 megahertz of CPU and 512 megabytes of memory. And then Alice is going to run the MongoDB task group that has a count of 2. So we're going to have a total of 4 allocations. And these MongoDB allocations want the same amount of resources. So that's going to mean a total of 1,000 megahertz of CPU and 2 gigabytes of memory. But based on the resource quota that we just looked at, that should be okay, right? Alice should be able to run that job. So let's go ahead and run that as Alice. We see that's running. It all looks good. We can come to the Nomad UI, switch over to the dev namespace, and click on the job. And we see that 4 instances, 4 allocations have been placed, and they're starting to become healthy. So that's all good. And here's the actual command we can use to check the status of a job in the CLI. Notice that when you do have namespaces enabled, you do have to specify the namespace flag. I think there's also a namespace variable, environment variable you could set instead. So we now have, let's go once more. Okay, now we have two healthy for each of the 2 task groups. So that's good. We were able to run that job. We should see everything healthy in the UI as well. Okay, now what we can do is let's just check the resource quota again for the dev namespace. And what we see here is now we're using 1,000 megahertz of CPU, and we're using 2,048 megabytes of memory, just as we had expected based on the job specification. So now what we're going to do is we're going to have Bob run the website QA Nomad job. This is very similar, uses the same, it's going to run in the QA namespace with the same website job name, but because those are different namespaces, there won't be a conflict. We're going to have Nginx with a count of 2 again. But here we see that Bob wants to use, because it's QA and he's doing a load test, he wants to use 1 gigabyte of memory for each instance. So down here for MongoDB, the same thing. So he's going to need 4 gigabytes of memory just to run this one job. Now, if we check the quota that's currently in place for the QA namespace, that's strange. Status QA. Okay, let me think about this. Nomad quota status QA. Match no quotas. That's very strange. Let's go in here. You know what I'm going to do? Let me just try that once more. Nomad quota status QA. How about we do this? Nomad stat quote. We saw it was created before. Let's do list. Okay, default and dev. The QA one has disappeared somehow, which is very strange. Let me do this. I'm going to go back here to where they were created, and we're going to fix this. So let me go down here. I'm going to navigate to the right directory. I have no idea how that happened. I've never seen that. I'm going to deploy this one. Okay, and now I'm also going to do Nomad. I want to make sure the namespace still exists. Nomad namespace list. Okay, and then Nomad namespace. I think it's, you know what, let me get a list of the commands. It should be inspector status. Let's do status. Status QA. All right, so that's associated with the quota, and we see what's going on. Okay, that's really strange. Okay, let's go back. We've recreated the quota. Let's go back here where we were, which was with the resource quotas. I'm going to navigate to the right directory, and we now are going to go down to where we were going to have Bob do a few things. Let's export his token again to make sure it's exported. And what we were going to do is we wanted to check the quota. Let's go back here to this command. All right, now we're good. So now we see 500 CPU being used out of 2,300 and 1,024 out of 4,100. Now remember, I had shown you the job and we saw that Bob wanted to use 4 gigabytes of memory. Well, there's only a total of 4 gigabytes on the whole server, right? So we're not going to have enough memory. But let's try to have Bob run this job anyways. And it does run, it starts, but he does get a warning saying memory exhausted on one node and that he hit a resource quota. This is saying that you know, he needed 5,120 altogether for both his job and the job that was already running, and that's greater than the limit of 4,100. Well, let's look at the Nomad UI, and let's go to the QA namespace. And if we look at this job, we can see we get the same red warning banner saying that, you know, there's a placement failure and only 2 of the 4 jobs are healthy so far. But let's do this. Remember, this job is technically still running, or the deployment is still running. You know, it says running here. So what Bob can do is Bob can actually, you know, take a look at what jobs he has in his namespace, in the QA namespace, and he can say, hey, you know, I don't really need the web server test thing anymore. I forgot that was running. So maybe he decides to stop that one. And you could do it in the UI, but let's actually do it with the CLI. So we're going to stop that job, the web server test job. And when we do that, and we come back here, now we're going to see that a new allocation has been deployed. So now we have placed the 4th allocation that was wanted for Bob's website job. And, you know, in a few seconds, now we see that all 4 allocations are healthy. So we see how the resource quota stopped Bob from, you know, doing something that was going to exceed his quota, and also how Nomad is flexible enough that if you stop a different job, now this job that had been incomplete can now finish, or the deployment can finish. So that's it. We should be able to check that we finished everything. Oh, it's giving me an error. It doesn't really matter at this point, but status of the dev resource quota 2nd time. I think, I don't know why that's missing, but let's just see if I check that. That was up here, this one. Let's try, let's try running that once more. And either way, I'll move on if this doesn't work. So let's go back here. Here, this also, yeah, something's going on with my resource quotas disappearing. I have no idea what that is. There's something odd here. Yeah, now I've lost the dev resource quota. I don't understand how that can be happening. Okay, anyways, let's go back. That's good enough. So let me come back to the slides because I do want to leave time for some questions. Let me move on and first share some links with you. This is the blog post. This is a blog post here about this demo, and you know, it talks about it a little bit. This demo is actually a modification or an update of an older demo I did more than a year ago. It's been updated mainly by the addition of Charlie as this extra user. And the old demo ran in AWS. The new one runs inside this instruct track in GCP, Google. But anyways, that's a link to the blog post. And then this is the instruct track that you can use if you want to run this yourself. So feel free to take a picture of that link or whatever, and we encourage you to run through this on your own. Also, I do want to mention again the Nomad hands-on workshop that's going to be next Wednesday from 10:30 to 3:30 Eastern time. We're going to cover, as I mentioned, we're going to cover the roadblocks case study, Nomad concepts and architecture, interacting with Nomad, Nomad jobs and drivers, running Nomad clusters and jobs, and then monitoring Nomad jobs. So you'll be able to actually step through 4 different instruct tracks that are similar to the one that I showed you, but more focused on some more basic. This is all focused on Nomad. This workshop's focused on Nomad open source features and capabilities, so there's nothing, in Nomad Enterprise there. Although we do have a second workshop, a Nomad Advanced workshop, that does go into more detail on that. So that's actually something that I have. This is a list of all the various HashiCorp workshops that we currently have created. And any of these, if you go to this, this particular URL here, it's hashicorp.github.io/workshops. You can get into, for instance, this introductory workshop and see what the topics are there, which I just showed you essentially. And there's also the advanced Nomad workshop that then goes beyond that and starts to cover Nomad security, job placement and variable interpolation, job update strategies, integration with Vault, running stateful workloads with Nomad host volumes, and then the Nomad Enterprise Platform features, and the Nomad governance and policy features, which I just covered today. So I've kind of started at the very last thing here, ironically, but those are the things that we do cover across those 2 Nomad workshops. So with that, let me just see if there was anything else in the slides. I think that was the last one. Yeah, that's it. So I'm happy to start answering any questions that you might have.
Okay, awesome. We did get a few questions while you're presenting. So the first one is, how wide is the non-containerized use case and what are the benefits of this?
So the benefit of the non-containerized use case are that Nomad, you don't necessarily have to take your legacy applications and convert them into Docker containers. You don't have to containerize them, right? So we have this isolated raw exec driver that, for instance, can run any arbitrary binary, like you saw me try to run the sleep job. And so that can be convenient. If you have some like I've done this, I mentioned the Nomad, that we have these other instruct tracks. In particular, we have a number for Nomad. And one of the tracks that, I've created some of these, but one of them is this job update strategies track. So Nomad supports doing updates of jobs, including you can do a rolling update, blue-green deployments, and canary updates, and you can do those for any job deployed with Nomad, for any application, whether it's a Docker-based application or whether it's a non-Docker-based application. So that particular track, what I do in there is I take a chat application that talks to a MongoDB database. It's actually a Node.js application. And I start by running it as a binary with the exec driver. This is the one that I just mentioned here. I run it with the exec driver, and then I convert it. I do a rolling update to change it to a different background. I change from a light colored background to a dark colored background, just changing the appearance of the application. And then I do a blue-green deployment to convert to a Docker version of the application. And then I do a canary deployment to change the background image again. So, but in general, for non-containerized applications and legacy applications, you can run those. You can run Java applications if you want. So as long as you have the Java SDK on each of the Nomad clients, which is easy enough to configure, you can then basically, Nomad has something called an artifact stanza. So effectively, you can run Java applications from Java jar files that you can download from a website or from an S3 bucket or something like that. So that's using the artifact stanza, where you're actually specifying the source, the location of your jar file, and also a checksum usually. So I hope that answered the question.
Yeah. And then the next one, does Nomad only support stateless workloads, or have you seen use cases where there is support for stateful workloads as well?
We do support stateful workloads. In particular, you'll notice here there's two different things within the job specification. One is called volume, which you're mounting or referring to a volume that you've set up within your Nomad client. So you mount the volume into the jobs or into a task group, so it's available. And then what you do is you map that to a certain location within each task. So here I have a volume mount, and I'm saying inside the task, inside whatever that might be, it's going to be available underneath, the data is going to be available underneath /etc SSL certs, but this is referring to the certs volume. So here we have certs on the volume is referring to this volume, which is referring to this source. Now that source is actually configured from the Nomad. This is part of the basic on the client. This is done on the client side. And so we can see down here that eventually there's a host, there's basically a host volume settings. There we go, host volume stanza, in which you're specifying, okay, where does this thing live on the server itself or on the client, on the Nomad client. Now, by the way, we have a number of, on the Learn platform, I should mention, that we already have implemented. If I go back to the workshops, there are two instruct tracks to let you walk through this. One is for Nomad host volumes, and there's another one that does integration with Portworx. So what I just showed you is using host volumes, but we support two other mechanisms. We support using Docker volume drivers, and the main driver that's used there, or that we've done work with, is we've partnered with a company called Portworx. So you can use a Docker volume, Portworx's Docker volume driver with Nomad. And then there's something called Nomad CSI plugins. The same CSI plugins that you might use with Kubernetes will also work with Nomad. And if we go to the Learn site, you'll see that there's 3 stateful workload tracks here underneath stateful workloads. You can go in and you can walk through, or like I said, now 2 of the 3 there we've implemented with Instruct. A third one is actually being worked on. So right now you have host volumes, you have container storage interface, CSI workloads for stateful workloads, and then you have stateful workloads with Portworx. So the first one and the third one, you can do an Instruct already. This one of my colleagues is working on this already. This particular challenge has you do everything in AWS. So it's a CSI plugin for an AWS EBS volume, but the Instruct track that my colleague, Tom, is working on is actually going to be using a Google persistent disk instead. Okay, so yes, stateful workloads, absolutely. Next question, Brianna.
And then there was a follow-up to that. So regarding stateful question, is the mount client specific? So if a job is ran on another Nomad client server, will it no longer find the location to mount?
Certainly the host volumes are client specific. You actually set up your, you're setting up your host volumes on these things. So you do have to be aware of that. Now, the good thing is Nomad is smart enough that if you set up a job specification like what I was showing before, where if you set up the job specification where you're using the volume or the volume mounts, it's only going to deploy that job to one of the, it's only going to deploy the job to a Nomad client that actually has that volume. So when you have this volume and it says, hey, the volume is looking for a source CA certificates, that source CA certificates, that's the name that you had to have used when you registered. Same thing with CSI plugins. Now the CSI plugins, I'm not 100% sure. We have this guide for CSI plugins. I forget, to be honest, whether they get mounted across all the Nomad clients, or whether it's specific. I think they get mounted across all the Nomad clients, but I'm not 100% sure. That might depend upon how you've configured things. But in any case, whether you have these host volumes or the CSI plugins, whether they're across all your clients or only some of your clients, Nomad is smart enough to only run the job where you want it. Now, there is one other point to mention here, which is that if you're using, let's say, just host volumes, Nomad isn't doing any synchronization between those different host volumes. So if you have the same MySQL host volume on 3 Nomad clients, you probably don't really want that unless you behind the scenes are doing some kind of synchronization. Now, Portworx takes care of that for you. In other situations, you may or may not have that synchronization enabled. So if you really if you don't want to deal with synchronization and you want to make sure that any application that runs that talks to a particular host volume will have the same data, then you probably should only run that host volume on a single client. Or you run something that takes care of that. Now, CSI, I think to a large degree, I think they take care of that synchronization to some degree. It would depend on what plugin you were actually using.
Awesome. Okay, so next one. Does HashiCorp have any example Sentinel policies to help us get started with policy enforcement?
We do actually. So now if the question is specific to Nomad, we have for all 4 of our major products, the ones that have enterprise versions, we do have guides called HashiCorp/Nomad guides and Terraform guides, console guides, and Vault guides. And if we look in here, I think this is under operations. Sentinel, here we go. So we do have some sample policies, a few things like all drivers, must be, this is probably saying driver must be Docker. There's a few other things here as well, right? So there's a few policies there, not a lot. Restrict Docker images. This one is saying, hey, here are the allowed images. So that at least gives you a flavor of what it's like to write, what it looks like, what the language looks like, but you'll probably end up writing your own Sentinel policies. Also, I should say that the original demo that I just showed you is in also under here. And this was the multi-job demo. And if we look here under shared and config, not config. You know what? This is under here. It's under AWS. I don't know why I put it here. Sentinel. So you can see the 3 policies that I mentioned all in here. So yeah, this repository has some Sentinel policies for Nomad. And if you look at the Terraform guides repository, you'll see a lot of Sentinel policies for Terraform.
Awesome. Okay, next, can you specify which Nomad client you deploy a job to, or does Nomad automatically choose the best within a namespace?
You can do that through several different ways. So parts of the job specification, there's something called a constraint, where you could do a constraint based on different things. Now, the constraint might or might not match a specific client, but there is an option of doing, basically based on the unique name of the client. So if you want to run a job on a particular client, you can absolutely do that. That's done. This track over here, by the way, Nomad Advanced Job Placement deals with some of that. So that deals with using a number of these things. So this uses, and there's what I just showed you was the constraint stanza. There's also something called an affinity stanza. The affinity stanza is like the constraint stanza, that's over here, but it doesn't, it's not an ironclad guarantee. Like, you're telling Nomad your preference, but you're leaving Nomad some flexibility to do something different if Nomad feels, can't satisfy, what you asked for. So there are these various things like affinity, the constraint stanza that I already showed you. And I think the track might cover the spread stanza as well, if you want to spread things out in a certain way, or if you want anti-spread. And then there's a number of different options there that can help you ensure that your Nomad jobs are running where you want them to run.
Okay, awesome. 2 more questions. So what are the benefits of running Nomad over other schedulers like Kubernetes?
The first benefit of Nomad, especially over Kubernetes, is just simplicity of the architecture. As I mentioned in the slides, we give you a single binary, same binary used for the Nomad client or for the Nomad client and servers. Also the same binary used for running the CLI, right? So it's super simple and to get started with. Also, there are some advantages in that, Kubernetes, right, requires you to pretty much Dockerize all your applications. And if you've already done that, or if that's all that's your only use case for using a scheduler, that's fine, right? Kubernetes can handle that. But like I showed you with regards to our task drivers, Nomad can do quite a few other things as well. It's not just about running Docker containers. We can use these other task drivers to run job applications and to run arbitrary binaries, or to run some of these other things that are in the community. Podman, which I think is Red Hat's essential. That's their standard now for doing containers. Singularity, jail tasks, right? A number of different things. And we're adding some support in the near future for something that will allow you to do, effectively, there'll be like a remote state. I think it's a remote task driver, which is that, and we have one customer doing that already, but essentially being able to do something like, instead of running the job on one of the Nomad clients itself, you might want to run the job inside, AWS Elastic Container ECS, right? You might want to run it in ECS, or you might want to, this customer in particular is running workloads inside Triton is from Joyent. So they're using a preview of this thing to run. So they use Nomad to do the scheduling and to manage the deployment of those applications, but the actual deployment is not being done to the Nomad clients, it's being done to this Triton platform that they're managing. So that's going to be available, I believe, in the Nomad 0.12 framework by the end of June or July, and that's going to give us additional capabilities and additional flexibility. So those are the main things. I think Nomad is very easy to manage. It's easy to use. Obviously, Kubernetes is very popular, and as a company, HashiCorp's doing a lot to have many of our other solutions interoperate with Kubernetes, right? Terraform and Vault both have support for Kubernetes. Consul does as well. But if you have legacy workloads or workloads that are not containerized that you would like to manage, be able to schedule, and get a lot of the same benefits of a resource scheduler deployment, you know, if it's something like a Nomad or a Kubernetes. Like I mentioned earlier, when I talked about the job update track that I have, you get the exact same benefits for, you know, most of the things that you can do in Nomad, that the benefits you would get for Docker applications, you get those same benefits for the non-Docker applications.
Awesome. Okay, so last question. Is it possible to integrate with Datadog to track activity and changes with Nomad?
You know what? We do have something called telemetry I'm not sure about what kind. There's Datadog integration that's more about reporting metrics out to Datadog. So you can export metrics about Nomad, about the, I think it's mostly about the Nomad servers and clients, but it might include, well, job and task status and runtime metrics to some degree. But there is some metrics that are collected and they can be pushed out to several different tools, including Datadog, Prometheus, StatsD. Could you repeat the question, Brianna? I just want to hear the second part of it about what they wanted to do with Datadog.
Yeah, so is it possible to integrate to track activity and changes with a Nomad?
I guess that depends on exactly, let's look at the metrics. We'd have to see what metrics get sent to Datadog. These are the key, you know, there might be some possibility there, but I'm not sure if it's necessarily at the job level. That's what I'm not totally sure about. These are the different metrics that are, I'm trying to see if there's anything Datadog specific. I don't think there is. So these are kind of generic metrics, but I think the key metrics, you know, you can see some certain things, but this is kind of more at a global level. It's not so much about, you know, deciding to do something. Now, one other thing I should mention, by the way, that might be interesting. Oh, this will be a tie into Datadog. Maybe this will. So one of the things we're currently adding, it's in preview currently, and I think it's in the, I don't know if it's in the documentation here up top or not, but we have something called an auto scheduler. So this is currently in a preview mode. I don't know if it's in the docs, but we have an auto scheduler. And there's two kinds of auto scheduling that can be done. The first kind is actually I'm looking for where this might be documented. The first kind of auto scheduling is to allow Nomad to dynamically change the count of a task group. And that's based on data that might be collected from something like Datadog. So it's more about, you could be monitoring your application. Let's say you've deployed an application with Datadog or something else. You have some kind of APM tool that's monitoring the application. You can feed metrics from Datadog or you know, AppD, AppDynamics, New Relic, whatever it might be. You can feed metrics from those APM type monitoring solutions into the auto scheduler. And then the auto scheduler will, initially what we have is that it will increase or decrease the task group count so that you scale your job up. And then also what we're going to have in the near future is the ability to expand or decrease the size of the Nomad cluster. So you could add additional Nomad clients or decrease the number of Nomad clients based on that auto scheduler. So I thought we had some docs about this somewhere, but I don't see it here yet. So but in any case, yeah, keep your eyes open for that. We do have, I think it's currently like in a preview of some kind. I think there's even a learn track about it. So I was in the learn track earlier. We should be able to find that. But I know we're kind of out of time here. But I think if you look at the learn track, I think there is one thing about auto scheduling in here. Let's just go through this. Maybe not. I thought I had seen something. But in any case, there must be a different kind of plugin. Yeah, that's different. Oh, load balancer. No, that's different again. That's about just regular load balancers. So I guess we don't have that documented yet, but that is something that you can expect to have soon. So okay. Auto scaling, and then again, the auto scaling will pick up metrics from Datadog and then base the decisions based on that, on what the Datadog reports. Okay, perfect. All right. That's it, right? Any other questions? You still there, Brianna? Okay. Oh, Ryan, are you still there?
Yep. It looks okay. Like we lost Brianna.
I think we lost Brianna. So, all right. Well, listen, thank you everybody who joined. I think we had a small group today, but we do appreciate your joining. Thank you, Pavel. Yeah, I might as well look at the chat and see if anything else has come through the chat that Brianna didn't Okay, I see there were some other people maybe responding.
Can you hear me?
Yeah, now we can, Brianna.
Okay, perfect. Okay, sorry about that. All right, so thank you for all your expertise on the questions. As I mentioned at the beginning, the Hangout was recorded and will be made available after post-processing, usually within a day or two. So I will email it out to everyone that registered, as well as it will be on our resource library on our website. So if you liked what you heard today and you want to join our workshop, as we mentioned, next Wednesday, May 20th, please feel free to go to our site, check out our events and workshops and register for that. And then also check out our Learn site, which is at learn.hashicorp.com. And with that, I think we're good to go. So I hope you all enjoyed today's Hangout, and thanks for joining us today. And a big thank you to Roger for his time, and have a great rest of your day.
And Brianna, one last comment is that this is, there is some information about the auto scaling, that's marked as beta in the job specification.